unit, that is state variable analysis. I will go with the state variable analysis. We already discussed so many techniques in order to analyze a system, right? The first, we can analyze a system by using a transfer function approach. In case of transfer function approach, what will happen? We are trying to neglect all initial conditions, right? And in case of time response analysis, how we have analyzed a system, and we have restricted a input as a 3 standard inputs we can use for a system in order to analyze the system, right? In order to overcome that, and in order to overcome that, in order to use the initial conditions, in order to use a different types of inputs for a system, if I take any input, that must be analyzable. So that is can be done by using a state variable analysis. And we can also discuss we also discussed about root locus stability analysis, right? So those are all alternative method in order to analyze a system by using a different method. This is another one method in order to analyze a system by using all the initial conditions. Along with that, we can also use any type of input for a system in order to analyze a system. So this is what state variable analysis. And what is the example we can take it for the state variable? What do you mean by state then? State is nothing but it is a dynamic system variable. And means, for example, if I take a cricket, in a cricket, what we are trying to do, so we are trying to have each and every ball's score, right? So for example, if I want to know about what is the first ball score, what is the second ball score, I can see that. So what is the first ball score, what is the second ball score at t, which is equal to t naught, right? So that is called state. So if in the dynamic system, the variables which are used to find out a state is called as a state variable. So if you are trying to form by using this variable, state variable, if you are trying to form a vector, we can call it as a state vector, that one. So these are all the things you already learned, I think so. And the next thing we have, that is state model equation. Means in a state model, in order to get the state model equation, what we'll do, we'll try to consider a state variable first and a state vector then in order to find out a state model equation, always we'll try to consider a solution for state vector first. Then this is a solution for state variable. Then this is a solution, that is x dash of t. So this is a state vector. It can be represented as x1 dash of t, x2 dash of t, x3 dash of t till xn dash of t. That must be equal to a into x of t, and this x of t is a state variables, and plus b into u of t, where u of t is input, and this is a output equation. So this output equation represents as y of t, which is equal to c into x of t plus d into u of t. Again, this is input and this is a state variable vector. And this is, see here, A also a matrix, but the matrix size is n cross n, and B is also a matrix, but the matrix size is n cross 1. This is a row matrix, and C is also a matrix. This is a 1 cross n matrix, means this is a this is column matrix, and this one is a C is a row matrix, and D is a constant term. So U of t, I already told, this is a input variable. And what we can call this A matrix we can also call it as evaluation matrix, and B matrix we can call it as control matrix, and C matrix we can call it as observation matrix, and D matrix we can call it as transmission matrix. And the size of the matrix is, if I consider A matrix means evaluation matrix, n cross n matrix. If I consider the B matrix means it must be a n cross m. M means this is the size of a output variable. So this is same as observation matrix means P cross n. N is again the size of input matrix is this, and D is transmission matrix. Again the size of the transmission matrix must be a P cross n again. And what are all the types we have? So in case of here, we have physical variable form and phase variable form, state model to transfer function, and state transition matrix. Along with that, we also have controllability, observability, and homogeneous equation. So many things we have. So under that, we are trying to discuss about physical variable form, phase variable form, and state model to transfer function for this class. So let's see what is this physical variable form then. In order to obtain a physical variable form, first what we need to do, we need to write a standard state equation. So when we can call it as a physical variable means if they are given an electrical system, in order to obtain a state model from this electrical system, so we need to use a variables for that. So how to use that variables if they are given an electrical system, so those variables we can call it as physical variable. So for that what we can call, for that first what we need to do, we need to write the standard equations first, then obtain the required state variables from the circuit and predict the order of the system, and solve the network using KVL and KCL, and equate the equation in differential form, form the state model matrices from the equations. So this is how we can get a we can get a state model from a physical variable. So let's see how we can get a state model from physical variable. Let's take one example. So I take an example here, that is RLC circuit we are consider here. Obtain the state model of the given electrical system. So here R and L which are connected in series, C is connected in parallel. So VI of T is input, V naught of T is output. And see here, in case of electrical system, the number of reactive elements which are present in the given network is nothing but which is a order of the filter. So how many reactive elements are present here? There are 2 reactive elements are present, so which indicates that this is a second order system. And again, the number of state variables which is equal to the number of energy storing elements which are present in given electrical network. And again, there must be a 2 variables must be present here, correct. And if I have an inductor means there is a current flowing through the inductor, we can take it as a variable, and voltage across a capacitor we can take it as a variable here. So the state variables we can represent as x1, x2, right. So input variables are Vi and Va0. And see here, the first variable, that is x1 of t, the current flowing through the inductor we can call it as a variable here, that is x1 of t which is equal to I of t, and x2 of t means this is a voltage across a capacitor. So across this capacitor we are measuring the output here. So x2 of t we can take it as V naught of t again. And input is nothing but u of t, right, according to the state model equation. So u of t which is equal to Vi of t, this is input variable. So if I apply a KVL for this circuit, we'll get Vi of t which is equal to R into I of t plus L into di by dt plus V naught of t. The voltage across the capacitor is V naught of t, right. So if I rearrange this equation, why we are rearranging means in order to have a equation in the form of x1 dash x2 dash, right. So because the differential, the first equation, state equation is x dash of t which is equal to A into x of t plus b into u of t, right. So if I want to have the equation in that form means I need to rearrange this equation in the form of di of t divided by dt. If I rearrange this one, we'll get 1 by L into Vi of t minus R by L into I of t minus 1 by L into V of t. But di of t divided by dt is nothing but x1 dash of t. Is it possible to rewrite like this? If I differentiate this one with respect to t means we'll get this. If I differentiate current with respect to t means we'll get x1 dash of t. So x1 dash of t we can rewrite means I'll try to replace this input current and V0 by the variables. So that is x1 dash of t which is equal to minus R divided by L into x1 of t minus where I of t is nothing but sorry, wait a minute please. So see here, minus R by L into I of t means it is a x1 of t minus this one 1 by L means V naught of t is nothing but x2 of t plus 1 by L into u of t. Why we are rearranging this one like this means I need to have the equation in the form of x dash of t which is equal to A into x of t plus b into u of t. So this is b into u of t and this one is a into x of t. Again x of t can be written as x1 of t, x2 of t till xn of t. So that's why I rearranged this one means minus r by l, I of t is nothing but x1 of t, minus 1 by l, v naught of t is nothing but x2 of t, plus 1 by l, u of t. So I'll call this one as equation number 1. Then next, I want to have a second variable equation, because it is a second order system, means there must be two solutions. That is, we can take what is the output voltage across a capacitor then. So the voltage across a capacitor we can write it as 1 by c integral of I of t. So if I differentiate this one with respect to t, means in order to cancel out this integration, take a differentiation on both sides, you will get dv naught of t divided by dt, which is equal to 1 by c into I of t. So this one we can call it as x2 dash of t. x2 dash of t we can rewrite as I of t is nothing but I of t is nothing but x1 of t. So x2 dash, which is equal to 1 by c into x1 of t. I'll call this one as equation number 2. So next, by using this equation number 1 and 2, we need to form a state equation here. So the state equation is nothing but x dash of t, which is equal to a into x of t plus b into u of t. So x dash of t we can rewrite as x1 dash of t, x2 dash of t. So which is equal to, this is a matrix that should be multiplied by x1 of t and x2 of t. So where a matrix is n cross n. So n means the number of inputs we have, 2 cross 2 matrices. So what is the input we have here? That is, the first one is minus r by l. The coefficient of x1 is minus r by l and the coefficient of x2 is minus 1 by l. The first row is over now. So what about a second row element here? So we have only a coefficient of x1 of t, we don't have a coefficient of x2 of t. So we can rewrite this one as 1 by x1 of t plus 0 into x2 of t. So both are same, right? So 1 by c, this is the coefficient of x2 of t is 0. So this is a matrix A. This is n cross n matrices now. Then what about B now? The B matrices means, so again by using a two equations we need to form a B matrices now. So in the first equation we have 1 by L here. So 1 by L, and in the second equation we don't have any input, so the input is 0 here. So this is called state equation for the given electrical network. And what about output equation now? That is y of t. So y of t is nothing but v naught of t, right? V naught of t, which is equal to x2 of t. So y of t, which is equal to c into x1 x2 plus d into u of t. And again in the output equation we don't have any x1 of t, means first input of first state variable. We have only a second state variable here. So hence the x1 coefficient is 0, x2 coefficient is 2 here. See here again, this is row matrix and we don't have any input here, so the input coefficient is 0. So the d value is 0 and the c value is 0 and 1. So this is output matrices. And next what we have, this is the first method, and the second method, that is by using a phase variables. So before discussing about that, how to represent a state diagram, means how to represent the state model in pictorial form. So by using the state diagram representation, we can represent a state model in graphical method or in graphical method. So in order to represent a state model in a state diagram, so we need mainly three elements. The first one is scalars, and the second one is adders, and the third one is integrator. Scalar means if I apply in the input and it should be multiplied by any scalar quantity. So here we are taken as a, so the output is x1 of t, so which is nothing but a into x2 of t. This is a scalar. Adder means it tries to add the element, that is inputs, that is x1 of t plus x3 of t, which is nothing but output is x1 of t. Then integrators means if I try to apply an input as a differentiated form, then I will get the original form, that is xn of t. See here, this is a differentiated form of xn of t, and we are getting the output of integrator as xn of t. So always the output of integrator, always we need to use a input to the integrator as a differentiated form only. And let's see how to write a state diagram for a state model equation. So this is a state model equation, right? So here we have here we have input, and this is state variable, and this one is output. So this is input and output. So it is clear that, so u of t is input, means input side we should have u of t. Then next, u of t should be multiplied by a scalar factor is b. So this is clear. Then if I have a plus means we should have one summer here. Then use a summer here. So the first term is over now. We are left out with a into x of t now. And output of this one is x dash of t, right? So the summing point output must be a x dash of t. I already told always the integrated input must be a differentiated form. So we have a differentiated form here. So it must be given as an input to the integrator. Then the output of integrator is x of t only. So we have a x of t now. What I need to multiply? The scalar factor a. So x of t must be multiplied by a, and which is given to the idle. So this equation is over now. Then next in the second equation, what I have, c into x of t plus d into u of t. So we have our x of t here. It must be multiplied by a scalar factor c. So which is given to again another one adder. So give it to the adder. And we left out with another one input, that is d into u of t. Here we have a u of t. It should be multiplied by a scalar factor d, and which is given to the adder, and which completes a this equation, and the output of this adder must be a y of t. This is a representation of state model by using state diagram. State model equation in state diagram. Then next what we have, let's see how to use a phase variable form. This is also called as canonical form 1. So obtain the state model of the given using canonical form 1 and 2. Equation can be differential or transfer function form. And represent the equation in block diagram form. From the equation form, the matrices of a state equation and output equations can be find out. So here represent the equation in block diagram form. There is no need. Every time you need to represent the equation in block diagram form. And see how the state model from a differential equation is nothing but phase variable form. Okay, so in order to get a state model from a differential equation means first I'll try to use a standard differential equation as a y power n. This is nth derivative. We can rewritten as dy power n divided by dn. Dy power n divided by dt power n plus an minus 1 y power n minus 1 plus an minus 2 y power n minus 2 plus till a1 y power y dash plus a naught y of t, which is equal to b naught u plus b1 u dash plus till bm minus 1 into um minus 1 plus bm into um. So let's see how to find out state model from this differential equation. So I'll try to consider a simple form of this one. So here we have multiple terms, right? So multiple input terms. Instead of considering a multiple input term, I'll try to consider only one input, that is b naught into u of t. And thus LHS side y power n plus an minus 1 into y power n minus 1 plus till an y dash plus a naught y of t. Yn is nothing but nth derivative. So next, choice of a state variable is output variable itself. Means I need to form a state variable from this, right? So state model equation from this differential equation means I need to choose a state variables, right? How to choose a state variables? First, always the y of t represent a first state variable. The first state variable we will always try to represent as x1 of t. So x1 of t is nothing but y of t. Then if I want to find out x2 of t means this is the differential form of in output, that is y dash of t. We can call this one as x1 dash of t. Then again y double dash of t we can rewrite as x3 of t. So again x3 of t means y double dash of t, which is equal to x1 double dash of t. We can also return as x2 dash of t. So it will continue till last term. The last term is here x1 dash of t is nothing but x2 of t, right? X dash of t is nothing but x3 of t. See here x2 of t is nothing but x1 dash of t, x3 of t is nothing but x2 dash of t. This must be x2 dash of t, sorry. and this one is xn minus 1 dash of t, which is nothing but x of n. How we can write like this? See here, I want to find out what is the solution of x1 of t, right? What we have x2 of t. If I have x2 of t, if I want to have a solution of x2 of t, what is the variable we have? x3 of t. Means the previous value must be contain the next value as a solution. So see here, we have xn minus 1 dash of t, which is equal to xn of t. So how to rewritten this one now? Y of t is nothing but x1, y dash of t is nothing but x2, y double dash x3, yn minus of t means xn. So this is y power n means differentiation of this one. So we can rewritten this equation by replacing it by state variables. So y power n means x power n dash of t. Then this is xn of t. This is xn of t into an minus 1 till a1 is nothing but y dash of t is nothing but x2 of t into a1 plus y of t is nothing but x1 of t into a0, which is equal to b0 into u. But I want a equation in the form of xn dash of t. So I'll try to rearrange the equation. If I rearrange the equation, we'll get minus a0 into x1 minus a1 into x2 till minus an minus 2 into xn minus 1 minus an minus 1 into xn plus b0 into u. So it is in the form of x dash of t, which is equal to a into x of t plus b into u of t, right? So shall we form our equation now? So the equation will be x1 dash of t, x2 dash of t till xn dash of n, which is equal to, in x1 dash of t what we have, so this is x1 dash of t, right? What is the equation we have? That is x2 of t. Means we don't have x1, we don't have x3, we don't have a x4 till xn. We have only a x2, means the coefficient of x1 is 0, the coefficient of x2 is 1 and x3 is 0 until xn minus 1. Sorry, till xn. And again similarly x2 dash of t, this is x2 dash of t is nothing but x3 of t. We don't have a coefficient of x1 of t, x2 of t, but we have a coefficient of x3 of t as 1, and remaining coefficient of variable is 0, 0, 0 and 1 till x power n xn is 0. And what about last one? For the last one we have an equation that is xn dash of t. For example, if I want to find out a third row element now, that is x3 dash of t. x3 dash of t is nothing but x4, right? So x4 means this is 0, this is 0, this is 0. The fourth element will be 1 and remaining elements are 0. So it will be keep on shifting. Then xn dash of n means how we can rewritten? See here, the coefficient of x1 is minus a0, the coefficient of x2 is minus a1, x3 is minus a2, x4 is minus a4. So it will continue still last term, that is an minus 1. So it completes a A matrix. It must be multiplied by x1, x2 till xn. And what about input matrix now? So input means we have considered only one input, we don't have a derivative, right? So we don't have a derivative means all the coefficients of inputs are 0 except the last one, that is b0. This is state equation. Then let's see output equation, how to write output equation. And again the output equation is y of t. It's obviously is nothing but y of t is nothing but x1. So we have only one variable, the remaining variable values are 0. See here, 1, the remaining values are 0. Plus d into u of t, we can't consider d into u of t because y of t we have only in one state variable. We don't have any input here. So the d variable value is 0 obviously. Sorry, d matrix value is 0 because the input is 0 here. So this is how we can form a phase variable equation by using canonical form. Then next what we have, how to write the state diagram for this state equation. See here, this is a state equation we have. For this you need to write a state diagram. See here, again the input is only one input we have here, that is b0 into u of t. always it goes from input to output, right? So b naught into u of t, there must be a adder must be present here because we have a plus, here. Next, the output of this one, what we are expecting here, that is xn dash of t. See here, xn dash of t means it shows that next we should have an integrator. Output of an integrator must be a xn of t, and it should be multiplied with an minus 1. See here, an minus 1, and we are indicating a minus here. And next, this one we are giving to the next integrate, means xn of t is nothing but it is a differentiated form of xn minus 1 of t. So which is given to the integrator again. The output of this integrator is xn minus 1 of t, and again there is a scalar factors are present here, that is an minus 2, here an minus 3. It will continue till a1. So here x2 of t means there must be x2 dash of t present here. Here x2 dash of t, which is nothing but x1 dash of t for this integrator input. The output of this integrator is x1 of t, and it should be multiplied with a constant or a scalar term a naught, which is given to the adder. The final one is output, that is y of t is nothing but x1 of t. This is how we can represent a phase variable by using a state diagram. So let's see one example based on this. Construct the state model using a phase variables if the system is described by the differential equation, that is d cube y of t dt divided by dt cube plus 4 into d square y of t divided by dt square plus 7 into dy of t divided by dt plus 2y of t, which is equal to 5 into u of t. Draw the state diagram for this. Let's see the solution. So it is a third order system. Third order system means first what we need to do, we need to choose a variable here. There must be a 3 state variables must be present. Third order of the system must be same as state variables, or a state variable must be same as order of the system. So I already told, if I want to write a state model, first we need to choose output as a first variable, that is x1 of t. So x1 of t is nothing but y of t then. So dy of t divided by dt means it is a differentiated form of x1 of t, which is nothing but x2 of t. So that is represented as y dash of t. Then next, the third variable d square y of t divided by dt square, x3 of t, which is nothing but x2 dash of t. Again, this is a second order differentiation. So next, what about the last one then? So which is nothing but x3 dash of t. Is it correct? So x1 dash of t is nothing but x2 of t. Correct. Then x2 dash of t is nothing but x3 of t. Then what about x3 dash of t then? So let's see that one. Means this derivative of this one we can represent as d cube y of t divided by dt cube is nothing but x3 dash of t. So if I rewritten this equation, we can rewritten as x3 dash of t plus 4x3 of t plus 7x2 plus 2 into x1 of t, which is equal to 5 into u of t. I want to find out what is this equation, right? x3 dash of t, because it is the only one variable in the solution form. So if I rewritten this one, we'll get x3 dash of t, which is equal to minus 2x1 of t minus 7x2 of t minus 4x3 of t plus 5 into u of t. So the state equation form is x dash of t, which is equal to a into x of t plus b into u of t. A is nothing but, this matrix is n cross n matrix. The input n value is 3, order is 3 here. So 3 cross 3 matrices we need to find out now. So what is A value then? So A is nothing but this is multiplied by x1, x2, x3, right? What is the coefficient of x1 in case of here? See here, what is the coefficient of x1 here? Which is 1, right? Sorry. And see here, we are trying to write a coefficient of x1, x2. The x2 coefficient is 1 here, and again x3 coefficient is 1. Means this is x1 dash, x2 dash, x3 dash, right? x1 dash is nothing but x2, right? The coefficient of x1 dash is only 1 is present. So x2 is present, remaining two variables are 0. So next, again x2 dash is nothing but x3 of t. We have only x3 of t, we don't have x1 and x2, so it becomes 0. Then x3 of dash means what is the coefficient of x1 we have? -2. x2 coefficient is -7. x3 coefficient is -4. So the a is over. It should be multiplied by x1, x2, x3. And what about b coefficient? Again there is two inputs are absent. We have only one input, that is it should be multiplied by a scalar, that is 5. It should be multiplied by u of t. And what is the output equation then? By using this, I already told the first variable always represent a y of t. So means y of t is nothing but x1 of t. So c must be a 1 0 0. It should be multiplied by x1, x2, x3, and d value is 0 obviously because we don't have an input here. Right here we don't have an input. So this is a state model equation for given differential equation. Then how to represent a state diagram for this? So this is the main equation. By using this you can write a state equation. So how many integrator must be present here? Because this is a third order system, there must be a 3 integrators. So u of t, 5 into u of t, 5 into u of t, that should be given to the adder, and output of this adder is x3 dash of t. It should be given to the integrator. Output of integrator is x2 dash of t, that is nothing but output of integrator is x3 of t is nothing but x2 dash of t. Again we are, it should be, so see here we have x3 dash of x3 of t, it should be multiplied by -4. So 4 into minus here we have, and next it must be given to the another one integrator. The output of the integrator is x1 dash of x2 of t. So see here we have a x2 of t, it should be multiplied by a scalar -7. 7 then minus, we are given to the adder. Then output of this integrator is given to the input to the next stage integrator. So that is x1 of dash t. Output of this integrator is x1 of t, which is given to the adder now, that should be multiplied by a scalar is -2. Then the final output is y of t is nothing but x1 of t. So this is a representation, state diagram representation of a given differential equation. Then next what we have, by using a state model we can also find out what is the transfer function of a system. So see here, this is a state model equation. So this one we can call it as a state equation, this one we can call it as a output equation. From this we can find out a transfer function. If I want to find out a transfer function, this is a standard equation, that is t of s, which is equal to, transfer function is nothing but output by input, that is y of s divided by u of s, which is equal to c into si minus a inverse into b plus d. So let's see how to find out a transfer function from a state model. So there is a derivation for this. Try to read it, the derivation of this transfer function. This is the final one, final equation we want in order to solve the problem. So let's see how to solve the problems of transfer function. So this is a given system which is defined by a transfer function y of s by u. Find the transfer function, that is t of s is nothing but y of s by u of s, where u of s is the input and y of s is the output here. So where x dash of t is nothing but they are given 0 1 0 0 0 1 minus 1 minus 2 minus 3. It should be multiplied by x. It is understood there are 3 state variables are present, and it is plus 10 0 0 u, and output equation is 1 0 0 x. So from this equation, from this state model, what we need to do, we need to compare this one with standard A state model equation, that is x dash of t is nothing but a into x of t plus b into u of t, y of t is nothing but c into x of t plus d into u of t. If I compare that one with this given matrices, then what we'll get, we'll get a matrix, we'll get a b matrix, we'll get a c matrix, and d matrix value is 0. So from that, what I need to find out, we need to find out what is Si minus A inverse first, because we know what is C, what is B, and what is D. So Si minus A inverse means, before finding out A inverse, let's see what is Si minus A here. Si minus I means it is an identity matrix, so it is n cross n matrix again. So we have S should be multiplied by identity matrix, that is 3 cross 3 matrices. If I multiply S with I, we'll get S0 0 0 is 0 0 0 S, and minus, we know that what is A matrices, right? write it here, and perform a subtraction, element by element subtraction, that is s minus 0, 0, s will get 0 minus 1 will get minus 1, 0 minus 0 will get 0, again second row with second row, 0 means 0 minus 0, 0, s minus 0, s, 0 minus 1 minus 1, and again 0 minus into minus 1 plus 1 will get 0 minus into minus 2 will get plus 2, s minus into minus plus in minus into minus 3 will get s plus 3. So this is s minus a matrix. So s minus a inverse we can find it out by using this one, that is adjoint of si minus a divided by determinant of si minus a. So how to find out the adjoint of si minus a here? So adjoint means, first what we need to do, we need to interchange the element here, that is minus 1 should come here, sorry, they have written a final transfer function here. First you need to form a adjoint. For example, I have 2 cross 2 matrices here. How to find out a adjoint matrix? We can interchange the elements, diagonal elements, these diagonal elements. Once we interchange the diagonal elements of from left to right, then what we need to do, we need to change the sign change here. This diagonal element must be a sign changed, right? Similarly, for a 3 cross 3 matrices also you need to do that one. And determinant of this one means, the determinant value is this is, that is s cube plus 3s square plus 2s plus 1. I think all of you know how to find out a determinant value, that is s into s plus 3 plus 2 minus into minus will get plus 1 into 0 plus 1, then 0 multiplied by 2 into 0 minus s, so we'll get 0 for that. So if I simplify that one, you'll get s cube plus 3s square plus 2s plus 1. So if I try to find out the adjoint value here, we are getting this value, then the b value is 10, 0, 0 from the given one, and this is a final one. If I simplify this one, if I multiply this one with c, we are getting a final answer as 10s square plus 10 into s square plus 3s plus 2, which is divided by s cube plus 3s square plus 2s plus 1. Thank you.